Hello. In this video we're going to be talking about the isosceles triangle theorem. And so we're all on the same page. Let's talk about what an isosceles triangle is first. An isosceles triangle is a triangle with exactly two congruent sides. So if I'm looking at the triangle ABC on the right there, then I can tick mark these two sides to show that these two are the sides that are congruent. And so that demonstrates that triangle ABC is isosceles because we have exactly two congruent sides. The isosceles triangle theorem follows that up to say, okay, well if we have a triangle that's isosceles, well then it has base angles that are congruent as well. Now, the base angles are the angles opposite the congruent sides. And when I say opposite, if we look at AC, the angle that's opposite AC is the angle that's made by the sides that are not AC. So if we just follow it across there, angle B is opposite AC, and angle C is opposite side AB. And so you can see down here, my base angles are angles B and C, and those are the ones that I marked. Okay, so we want to prove the isosceles triangle theorem is true, so I'm going to start doing a two-column proof to demonstrate that. So there are my two columns. Now, whenever we make a proof, we always start with our hypothesis. And our hypothesis here is that we have an isosceles triangle. Okay, so if we have an isosceles triangle, we can say triangle ABC is isosceles. And what's our reason for being able to say that? Well, that's what our hypothesis was, so we'll basically call that our given. That's what we were given. We were told that had to be true. Now in order to help ourselves here, I'm going to put point D here on BC so that D is the midpoint. So basically construct midpoint D. And we know we're allowed to do that because a line contains at least 2 points. We know we have point B and C on there, so I can certainly find point D. And now I'm going to bring down the segment from A to D. And again, I'm allowed to do that because, well, it'll say we'll make our statement create AD. And our reason will be 2 points form a line. Alright. Now, my goal here is to show that triangle ABD is congruent to triangle ACD. And if we do that, then we know that all the pieces inside those triangles have to be congruent. So starting with number 4. Well, the easy one, we know that AB is congruent to AC by reason of, well, it's an isosceles triangle, and we know we had to have two sides congruent. Another easy one to see in number 5 is that AD has to be congruent to itself. AD. Because everything's congruent to itself by the reflexive property. And then the last piece we know, we drew in point D so that it was going to be at the midpoint, and so I know that BD is congruent to DC. Reason being the midpoint theorem. So that's enough to show my triangles are congruent. I have 3 pieces shown to be congruent. They're all sides, so that allows me to say just what I wanted to say, that triangle ABD is congruent to triangle ACD by our side congruence. And then finally, in number 8, since we know our triangles are congruent, this tells me that angle must be congruent to angle C. And the reason we're allowed to say that is by our definition of congruent triangles. We knew that when triangles are congruent, all the pieces inside those triangles must also be congruent to each other if they're corresponding. B and C are corresponding to each other, so they must be the same. So that's our proof of the isosceles triangle theorem. We know that in an isosceles triangle, two of the sides have to be the same, and therefore two of the angles must also be the same. Okay, for now we are done.